Hello everyone, myself Navjot Singh. I am fourth year student at Thapar Institute of Engineering and Technology, where I am pursuing my BE in Electronics and Communication with batch number EC6. Today we are here to present our capstone project.
Hi, here Ananya Garg. I'm a final year student of Thapar Institute of Engineering and Technology, where I'm pursuing my Bachelor's of Engineering in Electronics and Communication.
Hi, here Tanu Kansal. I'm in my final year of engineering at Thapar Institute of Engineering and Technology, where I'm pursuing my Bachelor's of Engineering in Electronics and Communication.
Hello, my name is Kapil Sharma and I'm pursuing my Bachelor's of Engineering in Electronics and Communication at Thapar Institute of Engineering and Technology.
Hello, my name is Gurlal Singh. Currently, I am pursuing my Bachelor's of Engineering in Electronics and Communication at Thapar University. Diabetes is a major public health problem that is approaching epidemic proportions globally. Number of people with diabetes was 246 million in 2007 and likely to increase 380 million by 2025. Diabetic patients have to check their blood glucose content regularly using invasive approaches which enhance the risk of blood-related infections. Also, it is very hard to keep track of the glucose measurement on a daily basis. So, to mitigate this important issue, a portable system for non-invasive blood glucose measurement is researched, which we have used as our reference hardware. A machine learning model along with the website is developed, which take input from the reference hardware. Machine learning model will predict the glucose content of our body, which will further displayed on the user portal of our website.
The referenced hardware working is based on the principle of near-infrared spectroscopic technique using short NIR waves with absorption and reflectance of light with specific wavelengths of 940 and 1300 nanometer that helps to detect the glucose molecule from the human blood. As you can see in the figure, in the process, optical responses through the detectors have been collected from 3 channels simultaneously, that is, from the patient's index finger, middle finger, and ring finger. During measurement, the channel's data is collected in the form of voltages from 3 detectors. These collected voltages correspond to referenced blood glucose concentration. These voltages value are converted into decimal form using 4-channel ADS 1115 analog to digital converter. Coherent averaging has been done after collection of responses. So, the voltages collected from this referenced hardware will be sent to a machine learning model. So, coming to the flow of our project, when a user visits our website, if they are new to the website, they have to register first and then log in into their personal portal. After login, their previous glucose measurement will get displayed in a tabular form with time and date stamps. When a user enters new data, the data will be sent to a machine learning model for prediction. The predicted output will be received in the backend part of the website, and then the values will get updated in the database, which will then be displayed on the user's personal portal.
Now coming to the machine learning section of our project, we needed a model that would calculate the glucose content present in the blood by the given voltage values. As explained by our team members, that we will get 3 voltage values V1, V2 and V3 from the device. Here we are importing the modules and loading the dataset, and here we are visualizing the dataset. It's the relationship of V1 versus glucose, it's V2 versus glucose and V3 versus glucose. As the graphs are showing curvy nature, the main task was to come up with a model which gives accurate results in these type of datasets. After research, we found that multivariate polynomial regression would be suited best for this. A multivariate polynomial regression is a form of regression analysis in which the relationship between the independent variable x and dependent variable y is modeled on the nth degree polynomial in x. So a polynomial regression fits a non-linear relationship between the values of x and y. Here we are just dividing the dataset into training and test sets. Here we have used the polynomial features of degree 3, and here are its values. After training the module, we get the coefficients and the intercept values as it. Here we are predicting the values from test dataset and calculating the mean absolute error and the R2 score. Now, for the sake of testing, we are just predicting a single value.
Now we will do live demonstration of our project. So this is the landing page of our website. So here, like we can go to contact us page as well as about us. So suppose now we are as we are new users, so we will head over to register. So here we have to provide our email. So for example, gmail.com with name Gurlal Singh, password any password whatever we prefer. Now we can register here. So now it will head over us to the login page. So here we can log in like by putting our credentials, gurlal@gmail.com, and after putting the password. So now as we can see that like we have provided other features in login page as well, like if we go to forgot password, we can select our new password to our email ID. Other thing, if we are not even registered, we can go to register page from here as well. So now we will log into our registered ID which we have just registered. So this will head over us to our profile page. So as we are a new user, so nothing to display, so no data is available or linked to our ID right now. Now we will insert new data to our profile. So by clicking on this will head over us to the measurement page. So here we will put our values which are based on like hardware which is referenced in our project. So by clicking on this measure button, this will actually send this data to a ML model which is deployed on a remote server which is based on Flask, and then receive the predicted value and then save that predicted value under our unique ID. So by clicking on this, so as we can clearly see, here is the data available which we have just entered in this. Now we can also check data for already registered profiles. So like I have one. So for example, if I go and check for this profile only, yeah, so here we can clearly see the data available for profile which we have already registered, and the data will be inserted in this profile at this time duration, and the date is also given. So now as we have used MongoDB as our database, so in MongoDB cluster we have three models. So first one is entries. In entries, obviously the data will be stored linked to their IDs. Here the IDs, unique IDs, are email of a person. Session is basically model which will store the login logout time of every user. The user session will actually store the registrations of the users in our projects.